So guys, the first thing you have to remember in this chapter is about lens. That is the first topic basically. So what is lens over here? So lens is a transparent refracting medium bounded by either two spherical surfaces or one surface spherical or other surface plane. So for example, we have a lens over here, right? So it is a refracting medium bounded by two spherical surfaces or one spherical and other plane, something like this. This is called a lens. Then next thing is remember the kinds of lenses. Okay, so the lenses, the converging or known as convex lens, the concave or known as diverging lens. I hope you know what is it. Convex lens is this, and concave lens is something like this. Yeah. So basically, the convex is a converging lens. It is known to be converging because when the light ray passes something like this, it goes, converges. And at the focal point, at some point, the image is seen, eye is seen. But at the same point, at concave lens, looks like a branch of the tree, but still, forget that. And this is a ray passing through. It goes like this. This is called diverging lens. The ray, after striking this surface, it diverges. Then, what else we have? We have these three kinds of converging or known as convex lens. There are three types of convex lenses. It is biconvex, double convex, and equiconvex. First thing, that is this one. Plane convex and concavo-convex. In this chapter, you have to focus more on this. So just don't forget, just keep it in mind, these two. So then what else we have? Now, I guess that's it. We'll go to the next page. So here, again, three kinds of diverging and or known as convex lens, concave lens. Those are biconcave, double concave, and equiconcave. Same thing this. Then we have plano concave. Then this. Then then we had about the convex or concave. For the convex, it was concavo-convex, and for this it is convexo-concave. Right, perfect. Now, next thing is that then we have the next one is the next page, that is the technical terms related to the basically lens, not any lens. Yeah, this one. So here I have a small diagram which you can go through or which you can remember. They have given a diagram, but I hope mine is much simpler, and it's not a force though. You can just like try to look at mine. So I have an idea like this one, which we have learned in ninth. There's no difference. This is a lens, any lens, and this is the pole. Okay, and oh wait, I'll just draw it and meet you back. So guys, it just took a second. So here we have the pole. Here we have the center of curvature. I'll just write C, and the distance between the pole and the curvature is known as R, means radius of the curvature. And imagining what is this black line? This is called as, I hope you have already guessed it, principal axis. It is known as principal axis. So this is pole of a lens, means center. This is the radius of the curvature. This is the center of curvature. This is principal axis. That's it. And simpler as that. So we have covered these 4 points, actually 5 points in just one diagram. Simple. So then we have to go through the tables which are given in the upcoming pages. So it's this first focal point. We just have to go through. It's not important though. They'll not ask you in exam most of the time, but just need to remember what is it. So for the convex lens, the first focal point is a point F1 on the principal axis of the lens, such that the rays of the light coming from it after refraction through the lens become parallel to the principal axis of the lens. We have one more. It is known as the second focal length. Yeah, something like that. So we'll find second focal, it's here. So second focal length is, the second focal point is a point F2 on the principal axis of the lens, such that the rays of the light incident parallel to the principal axis after refracting from the lens pass through it. They have given an example. You can just go through it. As I said, this is a convex, and the light ray, what happens? It diverges. Perfect. They have given one more of the concave lens, which tends the, or maybe helps the lens to diverge from the path of the principal axis. And yeah, we've done it. Now on the right hand side, we have a note which says some of the things, but the thing you have to remember is only the third point. The convex lens has a real focus. Remember this, convex has real focus. And concave lens the focus is virtual. Sorry, I paused the video by mistake. Okay, cool. We'll continue. Then On the next page, we have some of the important things on again the left hand side. That is the note, which was given on the right hand side of the page. So here you have to remember the fifth point, which says fifth point, second sub point, that is the radii of the curvature of two surfaces of the lens. The thick lens has less focal length than the thin lens of same material. The radii of curvature of the two surfaces of lens, thick lens has a thick lens has less focal length than the thin lens of the same material. Others you can go through, it's about all about the lenses, the diverging, the converging, and all about lenses again. Yeah, same thing. So here you have to remember the differences between convex and concave. I'm just gonna put some marks. Okay, then convex lens, it is thick in the middle and thin in the periphery, sorry. It converges the incident ray towards the principal axis. It has real focus. And here it is thin in the middle and thick at the periphery. It diverges the incident rays away from the principal axis, as I said before. It has a virtual focus. Then we'll go to the next page. Oh, it's exercise. So we're gonna go more further. We have formation of, I got book, bro. So we have formation of image by lens. And the thing you have to read over here is go down, you have kinds of images. That's what you have to remember. In the kinds of images, here there are two kinds, the real and virtual. In the real image, what happens is the lens actually meet at a point the image is real. If the rays from the point of object after refraction through the lens actually meet at a point, the image is real. So that the image is obtained on it, the real image can be obtained on the screen, as they have given in the next page, the diagram. We'll go through that afterwards. Now come a little bit down, we have virtual image. What is virtual image? They appear to diverge from the point, therefore the image is virtual. Now comes the fun part, and before that we have the distinction between real and virtual image, that you gotta just read again. So real image and virtual image, same thing. They said real image can be obtained on the screen, virtual image cannot be obtained on the screen. Yes, these points are very important, just go through it, right? An example you have to remember. And yeah, next we have the drawing part, that is the construction of the ray diagram for the lens. This is going to be fun, but they won't ask you most of the times to draw it, but yeah, they may anytime. It's not, I'm not telling you that it's rare, they will ask, but it's not like for every single exam. They may give a gap for it. And so yeah, just gotta practice diagrams. Before that, we have to remember just one small table which belongs on the page number 116. I don't know what's the page number in this page. I have a 2024 book So yep, it is 115. No, definitely it was close. Never mind. So here you have to remember everything, like literally everything. No lie, this is very important, guys. Right? Yo, shit, damn. Okay, never mind. So we have position of object, cringe. Okay, we have position of image, size of image, nature of image, application. The thing you have to remember is only these four. Okay, these four are very important. This can be asked in MCQ. Yeah, that is, yeah, they will ask. Yeah, no lie. So then nothing much. We'll go, just go through it. So infinity, the position of image is at f2, beyond f2, between f2 and 2f2, at 2f1, at 2f2, between f1 and 2f2, beyond 2f2, at f1, at infinity, between the lens and f1 on the same side behind the object. So I've got a trick which I used in my exam. I don't know if that will help for you guys, but it I just kind of wrote something which I remembered, and this trick actually helps sometimes for some people. I don't know about you guys. So the trick is match the following. No lie. It's simple. Here it's 1, 2, 3, 4, 5. Leave the 6 behind, I'll tell you later. So 1, 2, 3, 4, 5, and go back at the same 1, 2, 3, 4, 5. Just match it. 1, 2, 3, 4, and there goes 5. Am I right? It's the same thing, right? Infinity goes to here, beyond f1, same thing here. F2, just here it's 2f1, it should be here 2f2, right? Here it's f between f1 and f2, 2f1. Here it should be between f2 and 2f2. Here it's f1, here it's f2. That's it. And the last thing is between the lens and f1, position of the image on the same side behind the object. That's it. And in the f2, yeah, position of f2, image is highly diminished. Between f2 and 2f2, diminished. 2f2 and uh it's f2 and it is same size. Beyond 2f2 it's magnified, infinity highly magnified. On the same side behind the object is magnified. It is magnified. Yeah, terribly ASMR, so never mind. We have nature of the image, real, inverted, real, inverted, real, inverted, real, inverted, real, inverted, virtual, and upright. So most of them are real and inverted. Yeah, so most of them are real and inverted. So virtual and upright is the only thing which where the object comes behind the lens or also behind the object, right? And it's magnified. So what does magnified mean? It basically means It basically means that image is bigger than the object. Yeah, yeah, you're right. Yeah. Okay, stop the shit. Okay, let's go. Then I just have to remember this table. For the concave, it's not necessary. And yes, we're done with the section B. Now we go to section C, which is all about sign convention and lens formula. This is all about you'll get to know. Okay, so first thing first, this is a lens. Okay, sorry, this is a lens. Anything on top is positive, anything on the right hand side goes it's positive, down negative, on top it's positive, this is also positive, and on this side it's negative, down also negative, left also negative. Okay, and we have this is for convex. For concave it's also the same thing. If you want to see, just go down and never mind, I'll already show you. Okay, look at this, look at this, look at me. Okay, so concave incident light, it goes like this: up is positive, right is positive, down is negative, left is negative. Correct. Same thing for every single lens. Therefore, you are negative. I mean, not you. You means object. Object is always negative. That is, this one is always negative because it is behind the lens, and anything behind the lens is always negative. Always remember this, or else you'll mess up with the formula. I actually messed up a lot of times, so yeah, never mind. Yeah, and this is the lens formula, which is very important for this for chapter, because most of the numericals also you can receive from here. And yeah, the formula is 1 by v, that is 1 by the image, 1 by u, that is 1 by object, 1 by f, that is 1 by focal length. Oh, they have given over here. Nice. Distance of the object, distance of the image, focal length. Then we go down and we have nothing much over here. Then note, here there is much to highlight. Just take a highlighter, just do it. Here, according to the sign convention of the convex lens, U is always negative, as I told you, F is always positive, and V is positive for the real image, and V is negative for the virtual image. Okay, but for the concave lens, U, V, F are all negative, and numerical value of U is always greater than V. Hope you get that. Then we have linear magnification. There is a definition which you have to import in: the ratio of the length of image I perpendicular to the principal axis to the length of the object O is called the linear magnification. Again, I'll read: the ratio of the length. Okay, give me a sec. There's a formula. Yeah. So ratio of the length of the eye, that is image, divided by I mean, yeah, the ratio of length of image I uh, is perpendicular to the principal axis to the length of object, that is this O. So this is called the linear magnification, and there is formula for this, and there actually that is a formula. So they will surely ask you this, or you may use this formula for the numericals which are given by the boards. So there's nothing to worry, it's easy chapter. Okay, you just have to remember the formulas, you just have to remember all the what do you say, the convex lens, the characteristics, and you know how to draw, you should know how to draw the diagrams, and I mean construction of the rays, light rays, and the converging diverging lenses. You will surely get a confusing and twisted MCQ questions on these kind of chapters. So you just have to just go through it thoroughly, basics compulsory, and I will go to the next page. Okay, so here what you have to remember is power of the lens. Power of the lens. This here you have to remember only three things under this topic. That is the power of the lens, the definition, the symbol. Excuse me. The unit. I mean the unit. The symbol D. That is diopter. Power of the lens formula. So we'll just go through it in just a minute or two. Let's go. The power of the lens, the deviation of the incident rays produced by the lens on refraction through it is a measure of its power. Right? The power of the lens is 1 by F in meters. In meters is very important. Don't forget. If you write the focal length in just what, in 15 centimeters or something, yeah, you're done, boy. Yeah, you'll be wrong. So I'm just helping you guys. So yeah, subscribe. Yeah, we good. So the its unit is diopter, D. So P means power of the lens is also said to be D, diopter. Diopter, diopter, same thing. Okay, no need to do a debate on this. Come on, guys, chill. You gotta chill. Chill like an Indian nigga. Okay, sorry. Then we have this. If two thin lenses are placed in contact, the combination has a power equal to algebraic sum of the powers of the individual lens. Important. Again, highlight this. I will also highlight with you guys. If two thin lenses are placed in the contact, the combination has a power equal to the algebraic sum of the power of the individual lens. So I hope you understood. So if two lenses are like placed in a contact, the combination has a power equal to the algebraic, sorry for the handwriting, so never mind, algebraic algebraic sum, not algebraic sum of the powers of the individual lens. Yeah, you good. You guys are correct. Yeah, we good. Okay, never mind. We'll go to the next page. Okay, we have applications. What is this? Magnific magnifying glass and application of lens. This is also kind of easy, so never mind. Here we have to know the magnifying power principle, just go through it. Okay, these first this first what is it, the first paragraph. Okay, first paragraph, and the formula is very very important. Again, as always, just highlight it. Magnifying to whatever we want. Magnifying power m equals 1 plus diopter anything divided by f focal length. Magnifying power m equals 1 plus diopter by focal length. That's how you get the magnifying power of uh, lens. Okay, so I guess we're done with the chapter. Yes, totally, we're done. Let's keep the book aside, and we're done for today. It's all not important. Just go through the diagrams. As I said before, the diagrams are very very important. And yeah, guys, hope you subscribe, like, and it's not a force though. If you like it, just enjoy learning. We'll see you in the next video. Till then, take care, guys. Everyone, stay safe. See ya. Peace. Take care. Bye bye.